All right, good morning, Wildcats. Here we are on Tectonic Plates, Chapter 3, Lesson 2, page 100. We have 1, 2, 3 sets of notes to take. So that means we'll do that for the first 3 days. And then we'll do our Phase 2, processing, highlighting, annotating, and our Phase 3 connecting on the 4th day. And then that'll give us Friday to put it all in our e-binder. Okay, first thing is the same. Write your name. Don't put my name. Put your name. Class or period. AVID, capital A, capital V, capital I, capital D, 6. Today's date is October 26th, so 10/26/2020. Up here at the top left, science, capital SCIENCE, FNT, capital F, capital N, capital T, phase, capital PH, ASE, the number 3, colon, connect, capital CONNECT. We're doing all the phases up to phase 3 connect. We're on chapter 3, capital CHP period is the abbreviation for chapter, number 3. Capital LES period is the abbreviation for lesson 1. Oh, I'm sorry, 2. Chapter 3, lesson 2. All right, looking back at my old notes, we need the lesson title and then the main idea. So you need your blue pen. If you don't have it, pause the video, go get it. Tectonic, capital TEC, TONIC, plates, capital PLATES. Main idea, capital MAIN, idea, capital IDEA, slash, capital E period, capital Q period for essential question, and a colon. The solid outermost layer of Earth is divided into large moving plates. Evidence for these plates includes the locations of earthquakes, volcanoes, and mid-ocean ridges. Okay, so the solid outermost layer of Earth, what do we call that? The crust. We learned that in a previous lesson. CRUST, divided into large moving plates. Crust, divided, DIV, ID, ED, into INTO, large LARGE, zoop, moving, MOV, ING, plates, PLATES. Period, because there's a new idea. Evidence. So, okay. Evidence, EVIDE, NCE, equals earthquakes, EARTH, QUAKES, zoop, volcanoes, VOLCANOES, zoop, mid-ocean ridges, MID dash OCEAN, ridges, RIDGES. So the crust is divided into large moving plates. Evidence for this includes earthquakes, volcanoes, and mid-ocean ridges. Okay, next up should be vocabulary words. First one is fault. FAULT. Says it's on page 101. There it is. A fault is a crack in Earth's crust along which movement takes place. So the fault is like the line or the crack where the plates are moving. Okay. Crack, CRACK, NIN, crust, CRUST, arrow, movement, MOVEMENT. So it can't just be any crack in the crust, it has to be where the movement is taking place. Next one, magma, MAGMA, says it's on page 102. Magma is melted rock below Earth's surface. Melted rock below Earth's surface. Okay. Oh, well, it's basically lava, L-A-V-A, but below, so I put parentheses, B-E-L-O-W, surface, S-U-R-F-A-C-E, close parentheses. So magma is the same thing as lava, but it's below the surface. Lava is when it gets above the surface. Plate boundary. Plate, P-L-A-T-E, boundary, B-O-U-N-D-A-R-Y. Says that's on page 104. Plate boundary. There it is. The edge of a tectonic plate is called a plate boundary. Okay, so edge of tectonic plate. Edge of tectonic plate. E-D-G-E of O-F. We don't even need to say tectonic because we know this whole section is about tectonic plates. So let's just put plate, P-L-A-T-E. Oh, okay, a boundary is like a line, right? It lets you know where the bounds are, if you're in bounds or out of bounds. So that's the edge of the plate. Seafloor spreading. S-E-A-F-L-O-O-R. Spreading. S-P-R-E-A-D. S-P-R-E-A-D-I-N-G. Seafloor spreading. Page 102. Right there. Go backwards to the start of the sentence. As the plates spread apart, magma flows up and fills the space in a process called seafloor spreading. So what they're talking about is the seafloors actually spreading apart from each other, and as it cracks and splits open, magma comes up through that crack that's spreading. So plates spread apart, magma flows up. Plates, P-L-A-T-E-S, spread, S-P-R-E-A-D, arrow, magma, M-A-G-M-A, flows, F-L-O-W-S. So seafloor spreading is when the plates spread apart and the magma flows up into that empty space. Last one, tectonic plates, T-E-C-T-O-N-I-C, plates, P-L-A-T-E-S. That's on the first page here. Go back to the start of the sentence. According to the theory of plate tectonics, the lithosphere is broken up into huge irregular slabs called tectonic plates. Okay. Slabs, S-L-A-B-S, of, O-F, lithosphere, L-I-T-H-O-S-P-H-E-R-E. Now we remember from previous lessons that the lithosphere is the crust and the upper mantle. So it's like that thin outer layer of the Earth and a little bit more. So underneath the lithosphere, let's put crust, C-R-U-S-T, plus upper, U-P-P-E-R, mantle, M-A-N-T-L-E. All right, now you need your red pen, continents and tectonic plates. Okay, let's skip a line. Continents, capital C-O-N-T-I-N-E-N-T-S, and down 3 down, tectonic, capital T-E-C-T-O-N-I-C, plates, capital P-L-A-T-E-S. Pencil, and let's read. In the 1960s, scientists proposed a new theory that expanded on Wegener's ideas. So remember last lesson we learned that there was this guy named Wegener, and he figured out that there were plates, and he used the fossil record and rock record to learn that. Now scientists are adding more to his ideas. This theory is called plate tectonics. Tectonics, tectonics, is the term for large-scale processes that deform Earth's crust. Okay, that's really important. That almost sounded like a definition right there. Okay? So, theory, T-H-E-O-R-Y, arrow, large, L-A-R-G-E, dash scale, S-C-A-L-E, processes, Processes. Let's come down and indent. Deform, DEFORM. Earths, capital EARTH''S. Crust, CRUST. So, plate tectonics is the theory that says there are large-scale processes which deform the Earth's crust. So a theory is an idea you can test. Large-scale processes mean it's very big, like the size of the Earth, almost bigger than we can imagine. And deforming the Earth's crust means things are moving and changing. Recall that the continents are part of Earth's crust. The crust in the upper part of the mantle formed a rigid rocky layer called the lithosphere. According to the theory of plate tectonics, the lithosphere is broken up into huge irregular slabs called tectonic plates. Okay, so we basically already know about continents. We already remember this part about the lithosphere because we wrote it here in our definition. And we already have the definition of tectonic plates. So we're done with that paragraph. It is the tectonic plates that move, not the continents themselves. The continents merely ride along top, like cargo on a container ship. Okay, so plates, PLATES, move, MOVE, zoop, continents, CONTINENTS, quote, ride, RIDE, unquote. So the plates are what's moving. The continents just kind of like ride along the top or are carried by the plates. Okay, that's why we put the little quotes, because they're not really riding it like a horse. All right, let's look at our picture. The Himalaya Mountains formed from the collision of the Indian plate and the Eurasian plate. Okay, so there are two plates, one in India and one in Eurasia. And when those two plates slammed together, it forced all of that rock up. You can actually see, like those straight lines there, that used to be flat and level with the ground. And when the two plates smashed together, all of those mountains got pushed up into the air. Okay, evidence of moving plates. That's a little subtitle, so let's use our pencil over here. Evidence, capital EVIDENCE. Evidence of moving plates is visible in places where plates come together, pull apart, or slide past one another. These places are found all over the world, including California. Okay, so California is actually pretty well known in the United States for having a lot of places where plates come together, pull apart, or slide past one another. Let's put those three things. Evidence. Pull apart, PULLAPART. Let's see, come together, TOGETHER, zoop, and then slide, SLIDE. All right, let's draw little arrows. Pull apart, draw a line, an arrow on each end. There we go. Together, let's draw two arrows pointing at each other. And then the slide past, draw a line, but you're only going to do half the arrow. Then draw another line and do the other half of the arrow down there. That is the symbol for the sliding. That's the symbol for shear stresses. It's kind of like a half arrow up and a half arrow down. All right, the Himalaya Mountains in Central Asia formed from colliding plates. These mountains are among the highest on Earth. They began forming about 65 million years ago when India collided with mainland Asia. The pressure caused the plates to buckle and fold, creating the mountains. This collision is still in progress today. Okay, so let's imagine that this part of the book right here is one of those continents. This will be the Asian continent. And let's pretend my hand is the Indian plate. As the plate comes up, it hit, and it kept pushing and pushing and folding and buckling. Well, now you see my knuckles are up in the air. That's the mountains. That's what happened. As they hit and pushed, it kept folding up and pushing up, and all the mountains got pushed up into the air. So let's say something like plates collide, PLATES, collide, COLLIDE. And then let's draw a little arrow, fold, FOLD, and down 3 down, buckle, B-U-C-K-L-E. Underneath all that, let's say push, P-U-S-H, up, U-P. Ah, I know. Let's draw a little picture. Right here, we're going to draw a squiggly line, and then another squiggly line with two little dots right there. And over here, though, we're going to draw that squiggly line with the dot. And then this one, the dot's going to be underneath. And it kind of like goes up, jagged like a mountain, down, and then straight out. So as they pushed together, it folded and buckled and got pushed up. Let's draw a little arrow pushing up right there. All right, in California, two plates are sliding past one another along the San Andreas Fault. A fault is a crack in Earth's crust along which movement takes place. As rocks in each plate grind past each other, pressure builds up. Eventually, the rocks break and shift. The sudden movement along the fault is felt as an earthquake. Okay, so let's put example, right? E period G period, San, capital S-A-N, Andreas, capital A-N-D, R-E-A-S, fault, capital F-A-U-L-T. Pressure builds up, P-R-E-S-S-U-R-E, builds, B-U-I-L-D-S, up, U-P. Break, B-R-E-A-K, zoop, shift, S-H-I-F-T, suddenly, S-U-D-D-E-N-L-Y. And I ran out of space, so go down here and put equals earthquake, E-A-R-T-H-Q-U-A-K-E. So, when pressure builds up, eventually it will break and shift suddenly. That is an earthquake. In places where plates pull apart, a rift valley or long narrow valley forms on Earth's surface. An example is the Great Rift Valley in East Africa. This 5,000 kilometer or 3,000 mile long rift began forming 35 million years ago. Okay, that 3,000 miles is about how far it is from the west coast of the United States to the east coast of the United States. So the rift is as long as our entire country. That's a huge rift. Okay, looking at our pictures, sliding plates will break apart any structure built across them. So you can kind of see how it looks like these little puzzle pieces of the road should fit together. And as they slid past each other, this one got pushed forward that way, and then this one got pushed down that way, and they moved and broke. Right? If you were a little tiny ant living on the edge of this, you might think this was the entire continent moving. Okay, down here at the northern part of the Great Rift Valley, the Rift Valley is filled in by the Red Sea. Okay, so looking at this map, right about here is where Egypt and the Nile River is, and you all are learning about that. So that's where things are splitting apart, right there. Okay, main idea. Describe evidence that supports the movement of plates. Okay, do we have evidence that supports movement of plates? Well, there's evidence. What evidence do we have? Plates seem to be moving, and the continents seem to ride on them. We find places where they're pulling apart, pushing together, or sliding past each other. We notice that when plates collide, they fold and buckle and push up and turn into mountains. An example here in California is the San Andreas Fault. And we know that when pressure builds up, eventually it will break and shift suddenly, and that is an earthquake. So that's one of our pieces of evidence about plate movement. Okay, that's it for day one. A little bit of a long one, but first day is always a long day. Good job persevering with the growth mindset. Roar, Wildcats!